To calculate the electrical load on a duplex in amps using the standard method, several steps must be followed. Firstly, calculate the general lighting load. Multiply the square footage of the unit by 3 volt amps per square foot. In this case, 1900 square feet multiplied by 3 volt amps per square foot equals 5700 volt amps. Secondly, calculate the appliance loads. List all the appliances and their volt ampere ratings. These include a 7000 volt amp range, a 1200 volt amp disposal, a 1320 volt amp dishwasher, a 3000 volt amp hot water heater, and a 20,000 volt amp central heating unit. Note that the central heating is assumed to be electric. Thirdly, calculate the air conditioning unit loads. Multiply the number of air conditioning units by the amperage and voltage. With 5 air conditioning units at 21 amps and 240 volts, the calculation is 5 multiplied by 21 multiplied by 240, which equals 25,200 volt amps. Fourthly, calculate the total load. Sum up the general lighting load, the appliance loads, and the air conditioning unit loads. The general lighting load is 5700 volt amps. The appliance loads total 7000 plus 1200 plus 1320 plus 3000 plus 20,000, which equals 32,520 volt amps. The air conditioning unit load is 25,200 volt amps. Add these together, 5,700 plus 32,520 plus 25,200, to get a total load of 63,420 volt amps. Fifthly, convert the total volt amps to amps. Divide the total volt amps by the voltage. Assuming a 240 volt system, divide 63,420 volt amps by 240 volts, which equals 264.25 amps. Considering this is a duplex, each unit has the same load. To find the load per unit, divide the total load by 2. That's 63,420 volt amps divided by 2, which equals 31,710 volt amps per unit. Convert this to amps per unit by dividing 31,710 volt amps by 240 volts. This equals approximately 132.13 amps per unit. It is important to consult local electrical codes and regulations, as they can vary and might impact load calculations. The National Electrical Code, or NEC, provides guidelines for electrical installations, including load calculations. One needs to verify that the calculated load is within the capacity of the electrical panel and service conductors. If the calculated load exceeds the capacity, upgrades might be necessary. Also, ensure that the wiring and overcurrent protection devices, such as circuit breakers, are appropriately sized for the calculated load. Remember that these calculations are based on the provided information and assumed values. A qualified electrician should perform a thorough assessment of the electrical system to ensure safety and compliance. These calculations only provide an estimate and should not be used as a substitute for professional advice. The distribution of loads across different phases in a 3-phase system should be balanced to prevent overloading any single phase. If the duplex is supplied by a 3-phase system, ensure that the loads are distributed evenly across the 3 phases to maintain balance and prevent imbalances. Also consider any future expansion or additional loads that may be added in the future. It is advisable to include a buffer or safety margin in the calculations to accommodate future needs. When selecting conductors, consider factors such as ampacity, voltage drop, and environmental conditions. The conductors should be sized appropriately to handle the calculated load without exceeding their ampacity rating. Voltage drop should also be considered to ensure that the voltage at the point of use remains within acceptable limits. Environmental conditions, such as temperature and humidity, can affect the performance of conductors and should be taken into account. Also, consider the demand factors that may be applicable to certain loads. Demand factors are used to reduce the calculated load based on the assumption that not all loads will be operating simultaneously. For example, the NEC allows for demand factors to be applied to certain appliance loads, such as ranges and dryers. When calculating the load for a duplex, it is important to consider the diversity of the loads. Diversity refers to the fact that not all loads will be operating at their maximum capacity at the same time. This can be taken into account by applying diversity factors to the calculated loads. Consult the NEC for guidance on applying demand and diversity factors. The service entrance conductors and overcurrent protection devices should be sized based on the calculated load, taking into account any applicable demand and diversity factors. The service entrance conductors should be sized to handle the calculated load without exceeding their ampacity rating. The overcurrent protection devices, such as circuit breakers or fuses, should be sized to protect the conductors and equipment from overloads and short circuits. When calculating the load for a duplex, it is important to consider the impact of harmonics. Harmonics are caused by nonlinear loads, such as electronic devices and LED lighting. Harmonics can distort the voltage and current waveforms, leading to increased heating and equipment malfunction. If the duplex has a significant amount of nonlinear loads, it may be necessary to install harmonic filters to mitigate the effects of harmonics. It's important to ensure that all electrical work is performed by qualified and licensed electricians. Electrical work can be dangerous, and it is important to follow all safety precautions to prevent electrical shock and fire. Electrical codes and regulations are in place to protect people and property from electrical hazards. It is important to comply with all applicable codes and regulations to ensure a safe and reliable electrical system. Additionally, regular maintenance and inspections are important for ensuring the continued safety and reliability of the electrical system. Electrical equipment should be inspected regularly for signs of wear and tear, and any necessary repairs or replacement should be made promptly. Electrical panels should be kept clean and free of obstructions to allow for proper ventilation. Also, consider the use of energy-efficient appliances and lighting to reduce the overall electrical load. Energy-efficient appliances and lighting consume less electricity, which can help to lower energy bills and reduce the strain on the electrical system. When replacing appliances or lighting, look for energy-efficient models that are certified by Energy Star or other reputable organizations. Also, consider the use of smart home technologies to control and manage the electrical load. Smart home technologies such as smart thermostats and lighting controls can help to optimize energy consumption and reduce the overall electrical load. These technologies can also provide valuable insights into energy usage patterns, allowing for more informed decision-making. When installing electrical equipment, it is important to follow the manufacturer's instructions carefully. A proper installation can lead to equipment malfunction and safety hazards. If you are unsure about how to install electrical equipment, consult with a qualified electrician. Also, consider the use of surge protection devices to protect electrical equipment from voltage surges. Voltage surges can damage sensitive electronic equipment and cause fires. Surge protection devices can help to protect against these hazards by diverting excess voltage away from the equipment. It is important to choose surge protection devices that are appropriately rated for the voltage and current levels of the electrical system. Additionally, consider the use of ground fault circuit interrupters, or GFCIs, to protect against electrical shock. GFCIs are designed to detect ground faults and quickly shut off power to prevent electrical shock. GFCIs are required in certain locations, such as bathrooms and kitchens, where there is a high risk of electrical shock. When working with electricity, always use appropriate personal protective equipment, or PPE. PPE includes items such as insulated gloves, safety glasses, and arc flash suits. PPE can help to protect against electrical shock, burns, and other injuries. It is important to choose PPE that is appropriately rated for the voltage and current levels of the electrical system. Remember to disconnect power before working on electrical equipment. Always disconnect the power at the circuit breaker or fuse box before working on any electrical equipment. This will help to prevent electrical shock and other injuries. Verify that the power is disconnected by using a voltage tester. Finally, test electrical equipment after repairs. After making any repairs to electrical equipment, it is important to test the equipment to ensure that it is working properly. Use a voltage tester to verify that the equipment is properly grounded and that there are no voltage leaks. If you are unsure about how to test electrical equipment, consult with a qualified electrician. The calculation previously shown yields 264.25 amps for the entire duplex and 132.13 amps per unit. These values are critical for safe and efficient operation. One needs to select the appropriate size of service entrance conductors, overcurrent protection devices, and other electrical components based on these figures. Moreover, this method assumes a standard voltage of 240 volts. Actual voltage may vary slightly, affecting the amperage. Also, the calculation does not include any potential future load additions. Therefore, the electrical system should have some extra capacity to accommodate future needs. Proper grounding is essential for safety. All electrical equipment must be properly grounded to provide a path for fault current to flow back to the source. This helps to prevent electrical shock and other hazards. Grounding systems should be inspected regularly to ensure that they are in good condition. Also, regular inspections are critical for detecting potential issues. It is advisable to have the electrical system inspected by a qualified electrician on a regular basis. Inspections can help to identify potential problems before they become serious. During an inspection, the electrician will check for things like loose connections, damaged wiring, and overloaded circuits. The electrician can also provide recommendations for improving the safety and efficiency of the electrical system. Furthermore, it is important to keep accurate records of all electrical work. Accurate records of all electrical work, including repairs, modifications, and inspections, should be maintained. These records can be helpful for troubleshooting problems and for planning future upgrades. The record should include information such as the date of the work, the name of the electrician who performed the work, and a description of the work that was done. The initial calculation provided a base understanding, but one needs to consider other factors. Consider the impact of power factor correction, especially for inductive loads. Power factor is a measure of how efficiently electrical power is used. Inductive loads, such as motors and transformers, can cause the power factor to be less than 1. A low power factor can lead to increased energy consumption and reduced system capacity. Power factor correction can be used to improve the power factor, which can help to reduce energy consumption and improve system performance. It involves adding capacitors to the electrical system to counteract the effects of inductive loads. Consider the impact of voltage fluctuations. Voltage fluctuations can affect the performance of electrical equipment and can even damage sensitive electronic devices. Voltage fluctuations can be caused by a variety of factors, such as changes in the load in the electrical system or problems with the utility grid. If voltage fluctuations are a concern, it may be necessary to install voltage regulators to stabilize the voltage. Also, consider the impact of transient voltage surges, or TVSS. TVSSs are devices that are designed to protect electrical equipment from transient voltage surges. Transient voltage surges can be caused by lightning strikes, switching operations, and other events. TVSSs work by diverting the surge current away from the electrical equipment and into the ground. There are several different types of TVSSs available, including surge protective devices, or SPDs, and transient voltage surge suppressors, or TVSSs. Now consider energy management systems, or EMS. EMS are systems that are designed to monitor and control the energy consumption of a building or facility. EMS can be used to identify areas where energy is being wasted and to implement strategies for reducing energy consumption. EMS can also be used to optimize the performance of electrical equipment and to improve the reliability of the electrical system. They can include features such as real-time energy monitoring, automated demand response, and predictive maintenance. Demand response is a strategy for reducing energy consumption during peak demand periods. Demand response programs are typically offered by utilities as a way to manage the load on the grid. By participating in a demand response program, building owners can earn incentives for reducing their energy consumption during peak demand periods. Predictive maintenance is a strategy for preventing equipment failures by monitoring the condition of the equipment and predicting when maintenance will be required. Predictive maintenance can help to reduce downtime and to improve the reliability of the electrical system. Consider the use of renewable energy sources. Renewable energy sources, such as solar and wind, can be used to reduce the reliance on fossil fuels and to lower energy costs. Solar panels can be installed on the roof of a building to generate electricity. Wind turbines can be used to generate electricity in areas with high wind speeds. If renewable energy sources are being used, the electrical system must be designed to accommodate the integration of these sources. This may involve installing inverters, transformers, and other equipment. As a summary, it is extremely important to have a detailed electrical plan that complies with all local and national codes to ensure safety and efficiency of electrical distribution.